Alright, so today we're gonna do partial fractions, but we're gonna try to split improper fractions into partial fractions, essentially by dividing the numerator by the denominator and then looking for the remainder and expanding that in the usual way we've done partial fractions before. So the question I'm gonna attempt is 3x squared minus 3x minus 2 all divided by x minus 1 x minus 2. Alright, so the first thing we're gonna do is just expand this. That's just 3x x squared minus 3x minus 2 divided by x squared minus 3x plus 2. So now the first thing we have to do is divide this by this, so we're going to use algebraic long division to solve this problem. So x squared minus 3x plus 2 3x squared minus 3x minus 2. Now I haven't made a tutorial yet about long division. That's actually a good idea to do that. I'm just assuming for now that you have the knowledge to do this. So for basically you try to see how many times x squared goes into 3x squared. That's 3 times, so you put a 3 up here. Now you do 3x squared, then you do 3 times minus 3, which is minus 9x. 3 times 2 is just plus 6. You subtract. It's essentially like normal long division, with a twist of having to do it with algebra and x's and stuff. But so now you subtract this from this, so minus 3x minus 9x. That's going to give you 6x. Minus 2 minus positive 6. That's just going to give you minus 8. So that's the remainder. So now basically you say that this over here is equivalent to 3 plus the remainder divided by the denominator over here, which is x minus 1, x minus 2. So what we're going to do now is use the usual method for partial fractions to expand this. So let's see, 6x minus 8. I'm going to set up the problem as we've usually done for partial fractions. That's setting the equivalence relationship like this. Multiply this out. That's just going to give you divided by x minus 1 x minus 2. Alright, so you've got that. Basically, so we're going to use the usual method. We let the numerators equal each other, so 6x minus 8 equals a times x minus 2 plus b x minus 1. Now if we let x equal 1 here, 1 minus 1 is 0, so let's do that. Let x equal 1. 6 times 1 minus 8, that's just minus 2, and 1 minus 2 is minus 1, so that's minus a. So a equals 2. Let's do the same for b. So if we make x equals 2, then 2 minus 2 equals 0, the a part will go. Let x equal 2. 2 times 6 is 12, minus 8 is 4. Over here, 2 minus 1 is just 1, that's just b equals, so that's straight up the answer, b equals 4. So now we can conclude from the original question, which was this over here. We found the division from it. This is the remainder. We've expanded the remainder using partial fractions, so now we can conclude that 3x squared minus 3x minus 2 over x minus 1 x minus 2 equals 3. So basically we've expanded this, so we have the 3 from over here, which we've calculated by long division, plus a equals 2, so 2 over x minus 1, and now b equals 4, so plus 4 over x minus 2. So that's your question done. You might be wondering why these techniques are useful. These techniques are useful because in integration, if for example you're given this integral over here, you can't do it in any other way but using this method, simplifying it to this, and then integrating this. I'm gonna make a video about that shortly, so stay tuned. Thanks for watching. Visit my website, simplifyingmaths.com. We have some great services like doing your homework or personal tutoring via Skype or personally tailored tutorial video. So yeah, thanks for watching.